The teaching at Vedantu was amazing. One aspect where Vedantu teaching differed from a normal offline coaching was the attention teachers gave to our doubts. No matter how many times we asked a doubt, the teachers would patiently clear the doubt every single time. And they made learning a very fantastic experience for us.
Hi guys, क्या हाल चाल है भाई? Hello Shiv, hello Ajay. This is Saurav here and welcome to another session on Online Pathshala. In this session for grade 12, we'll be discussing behavior of ions. And until now we have covered a substantial amount of stuff. Wednesday I was not able to take the class because of my injury. Anyhow, I'm fine right now and we will be discussing behavior of ions, and the only thing which is left out in this topic is Kohlrausch law. Okay, so hello Lavi, hello Rahul, hello Ayush, hello Anupam. Very lovely to see you guys over here, and this is the second last lecture on electrochemistry. Next session जो होगा वो quiz होगा, in which we would be discussing questions which have come in previous years, and that will be a mixed bag of questions. But before going ahead, please do like, share and subscribe the channel and let others know that we are conducting live classes every day. Also, there are KPY classes which are being held at 8 to 9 for SA and SX segment. Hello Umesh. So electrochemistry आप देख रहे हैं सारी चीज़ें ब्लू हो चुकी हैं, इसका मतलब हम लोग ऑलमोस्ट सब कुछ कवर कर चुके हैं. आज की क्लास में हम लोग कोलरस लॉ भी कवर कर देंगे. So everything is done. Galvanic cells, electrolytic cells, behavior of ions, Faraday's laws. So behavior of ions के अंदर ही हम conductance and Kohlrausch laws cover कर रहे हैं. And Nernst equation, characteristics, concentration, cells, problems on that we have already done. Okay, so please do review those sessions. If you have a doubt on that, please do review those sessions in the playlist. There is a defined playlist for electrochemistry. पूरा देखिए, अच्छे समझिए, question solve कीजिए and be as confident as possible in the forthcoming examination. So it's not the last class, it's the second last class. आज quiz नहीं है. Wednesday की जो क्लास हम लोग नहीं कर पाए थे उस क्लास को आज हम करेंगे. ओके, न्यूमेरिकल पर पकड़ कैसे बनाएं? न्यूमेरिकल को पकड़ बनाने के लिए न्यूमेरिकल सॉल्व करना होता है. ओके, किसी चीज़ में मास्टरी करने के लिए यू हैव टू टेक ऑन टू दैट on a daily basis. Okay, every day कोशिश कीजिए कि 10 numericals solve करो in about 15 minutes time yourself, and maybe like in some time you will become better. Okay, so let's start today's session with this idea कि हमें मालूम है कि conductance क्या होता है, molar conductance क्या होता है, conductivity क्या होती है. Okay, molar conductance we have already discussed, molar conductivity we have already discussed. Let's talk about how does dilution affect both of these things. When we perform dilution, we add more water. Okay, when we perform dilution, we add more water. Suppose there is a solution of sodium chloride. एक हमने solution बनाया है. Okay, for example, I have taken 10 ml. I have taken 1 liter. In both of them I have added sodium chloride. For example, मान लेते हैं बहुत ही कम अमाउंट हमने डाला है. Let's say 1 gram of sodium chloride I have added in both of them. I've added 1 gram of sodium chloride in both of them. Now what will happen? 1 gram of sodium chloride will dissociate to give Na plus ions and Cl minus ions in both the cases. Okay, 1 gram of NaCl will dissociate to give Na plus ions and Cl minus ions in both the cases. Now to what extent it will dissociate is a big question. NaCl एक strong electrolyte होता है. NaCl is a strong electrolyte and it will dissociate to an extent of 100%. Okay, Erin, Parveen, if you don't what you don't understand, please do write that. Okay, so just writing I don't understand does not complete the sentence. Okay, so 1 gram of NaCl will dissociate completely, complete dissociation हो जाएगा. So whether it is 10 ml of water or whether it is 1 liter of water, it will dissociate 100%. If that is the scenario, we measure the molar conductance for in both these cases. Molar conductance takes into consideration how much the ions can move. So अगर 100% ions dissociate कर गए हैं, if 100% ions are dissociated over here, 100% ions are dissociated over here, so salt is dissociated to an extent of 100% in both the cases, I should get the same value of molar conductance in both of them. Okay? We should be getting the same value of molar conductance in both of them. 100% dissociate हो गया तो दोनों में सेम मिलना चाहिए. लेकिन होता क्या है, सेम नंबर ऑफ आयॉन्स हैं, लेकिन होता क्या है, इन दिस केस द conductance is slightly higher. I'll explain this why, but let's try and understand that molar conductance increases with dilution due to lesser interionic attraction. What happens? This was explained in the last class as well. इसको हम समझते हैं अच्छे से. If there is Na plus, around it chloride ions are present. Okay, around it chloride ions are present. Okay, if there is Na plus, there is chloride ion present around it. इसके around बहुत सारे chloride ions present रहेंगे. Now there is a separate scenario. This force of attraction is electrostatic force of attraction. Now, force of attraction will be inversely proportional to the dielectric constant. जो डाइलेक्ट्रिक कांस्टेंट होता है वो इस बात पर डिपेंड करता है कि आपने कितना डाइलेक्ट्रिक लिया है. इफ यू हैव टेकन लेस अमाउंट ऑफ वाटर, इफ यू हैव टेकन लेस अमाउंट ऑफ वाटर, देन फोर्स ऑफ अट्रैक्शन विल बी स्टिल परसीवेबल. लेकिन अगर आपने ज्यादा पानी ले लिया है देन उनके बीच में डिस्टेंस ज्यादा हो जाता है. Okay, so suppose this ion is moving in this direction, cation is moving in this direction, anion is moving in this direction. Suppose they're moving in opposite directions. Obviously they move in opposite directions because cation goes to the cathode, anion goes to the anode. They will move in opposite directions. If they are moving in opposite directions, what will happen? They will, if they attract each other, then their motion will be retarded. अगर दोनों के बीच में attraction है तो ये slow move करेगा और ये भी slow move करेगा. Can we say this? Can we say this? If the cation is moving in this direction and anion is moving in this direction and there is attraction between them, then they will move slowly. Their mobility will be less. But if they have a substantial distance between them, इनके बीच में काफी डिस्टेंस है, तो ये इधर मूव कर रहा है, ये इधर मूव कर रहा है, इनके बीच में डिस्टेंस ज्यादा है, एंड बिकॉज द डिस्टेंस इज मोर दे डू नॉट फील द अट्रैक्टिव इंटरैक्शन एंड दे कैन मूव क्वाइट इजीली. ओके, दे कैन मूव क्वाइट इजीली. सो दिस scenario is observed when we dilute a solution of sodium, any strong electrolyte. आप strong electrolyte के जगह आप ले लीजिए H2SO4 और HCl और NaCl और sodium acetate. You take anything, this will be observed. Okay? Now, next thing, for a weak electrolyte, what will happen? If I take a weak electrolyte, you must have read this particular thing that alpha is equal to root over K upon C. You must have read this. Okay, alpha is equal to root over K upon C. If alpha is equal to K upon C, what is C? C is concentration. Concentration means number of moles per unit volume. So I can write this as K by N upon V, which can further be simplified as K times V by N. So if I increase the volume, what will happen to alpha? Alpha value will also increase, and so for weak electrolytes, when you dilute, when you perform dilution, you're increasing the volume, the alpha value will increase. Alpha is nothing but the degree of dissociation, and if degree of dissociation increases, the number of ions present in the medium increases, also the molar conductance increases. Okay? Is that understood? Okay, so fine. चलिए, ये तो हो गई मोलार कंडक्टेंस की बात. But if I talk about conductivity, the conductivity of a solution decreases. को याद रखो, because this is asked in examination. Conductivity of a solution will decrease due to decrease in the number of ions per unit volume. When you perform dilution, आपने water ज़्यादा add कर दिया for the same amount of substance, so the number of ions per unit volume is decreasing, and so the conductivity will decrease. Okay? Is that clear? So let's move ahead and let's talk about what is the plot of molar conductance and concentration. We observe a plot like this. Okay, we observe a plot like this. The variation of molar conductance and concentration takes place like this. How do we understand this? Okay, इसको समझने के लिए we need to understand a simple equation. Molar conductance is equal to molar conductance at infinite dilution, इसको आप infinity भी कर सकते हैं, minus b root c. You can see that molar conductance is being plotted versus concentration, square root of concentration. If I take weak electrolyte, आपने weak electrolyte में water डाला, so let's say earlier the concentration was somewhere over here. This represents high concentration. This represents high concentration. When you add water, you are decreasing the concentration. So you can see that the conductance is increasing slowly and ऐसे increase करेगा. It will increase in a exponential manner. Okay, it will increase in a exponential manner. If you take a strong electrolyte, then the number of ions are already the same in both type of solution. Okay. The number of ions is same in both the solutions. So if I take a solution volume whose is 1 ml and contains 1 gram of NaCl, and volume which is 100 ml and which contains 1 gram of NaCl, the number of ions is same. The number of ions is same. Rahul Singh, इसलिए क्योंकि concentration जब आप increase करते हो, वैसे वैसे number of ions के बीच में attraction increase करता है, conductance decrease करना शुरू करता है. So it will always decrease with concentration, increase in concentration, और अगर आप concentration decrease करते हो तो conductance increase करता है. So ये पहले हमने इससे पहले वाली slide में हमने पढ़ लिया. Okay, so if I look at a strong electrolyte, the strong electrolyte can be seen that it is increasing very slowly. Why it is increasing very slowly? Because number of ions तो constant है. Number of ions constant रहेंगे. So what will only increase is the distance between the ions. Distance between the ions एक limit के बाद बहुत ज़्यादा increase नहीं करता है. So the value will increase very very slowly. Okay? The value will increase very very slowly. ठीक है? So with this idea in mind, याद रखो इस चीज को कि strong electrolyte जो होता है, I can calculate the molar conductance of a strong electrolyte at any concentration or even at infinite dilution, but weak electrolyte is just going parallel to the y-axis. It just keeps going parallel to the y-axis. It doesn't touch the y-axis completely. So to calculate that, we use the application of Kohlrausch's law. Okay, let's go to what Kohlrausch's law is. So Kohlrausch's law suggests that suppose you are performing dilution, and dilution आपने इतना कर दिया है कि वहाँ पे ions 100% extent में present हैं. Okay, they are present to an extent of 100%. So let's look at what Kohlrausch's law says. The Kohlrausch's law states that the equivalent conductance of an electrolyte at infinite dilution is equal to the sum of conductances of cations and anions. So at infinite dilution, when it be infinite dilution का मतलब cation and anion are separated infinitely away from each other, so they are moving independently, and since it is moving independently, I can just add the conductance of cation and anion and get the result. So it is based on three important concepts, or you can say there are three important parts in this. So first thing is, it discusses the combined effect of mobility and dilution. Mobility will increase with dilution. If you have more dilution, mobility will be higher. Mobility can be understood as the movement of ions, and dilution can be understood as the extent to which you are separating the ions. So if you are separating the ions to a larger extent, they will move quite easily, and so we can do this. Molar conductance increases with dilution till a limiting value. It will not increase infinitely. एक limiting value आता है जिसको हम बोलते हैं molar conductance at infinite dilution, lambda m power, or you can say the superscript is infinity, which suggests that it is molar conductance at infinite dilution. Okay, it is infinite dilution and it is obtained at infinite dilution. So when you what is the experiment? What you do is, let's take a certain amount of water, उसमें अपने एक electrolyte add किया, you start measuring the conductance. Okay, conductance हम measure कर रहे हैं, measure करते and you, how do you measure it? You add different amount of water in it. So earlier it was 10 ml, you add some 5 ml to it, 5 ml, another 5 ml, 10 ml, until the volume increases to such an extent that you do not see a change in the molar conductance. Then you would say that yes, my molar conductance value has reached the condition of infinite dilution. Okay, infinite dilution. So this is very vital कि हम calculate कैसे करते हैं. एक solution लिया, उसमें कुछ salt present है, उसमें कुछ water present है, and you measure the equivalent molar conductance. मोलार कंडक्टेंस वहां पे मेजर किया, फिर उसमें कुछ वाटर डाला, करते करते यू टेक मल्टीपल रीडिंग्स. द पॉइंट व्हेन इट बिकम्स कांस्टेंट फॉर no matter whatever volume of water you are adding, you say that now it has reached the condition of infinite dilution. That is the limiting value. Okay, at this dilution, इस dilution पे क्या होगा? Cations and anions will move independently. At this dilution, cations and anions can be moving independently of each other, and if they are moving independently, then उनके बीच में कोई attraction नहीं है. So I can use this. If n represents the number of cations, n minus represents the number of anions, molar conductance at infinite dilution for cation is given as lambda plus infinity, and molar conductance at infinite dilution for an anion is given as lambda minus infinity. Then total molar conductance will be equal to this. This is Kohlrausch law. Okay, zero concentration पे पहुंचना बहुत मुश्किल है शिव. Zero concentration हम पहुंच नहीं सकते हैं. We can only go up to there. Okay, zero concentration का मतलब there is no electrolyte present. तो आपने पानी डालना शुरू किया तो concentration can only decrease. It cannot become zero. So we get tending to zero, concentration tending to zero मिलता है हमें. So total molar conductance at infinite dilution is the number of cations times molar conductance at infinite dilution for cations, number of anions times molar conductance at infinite dilution for anions. Exactly यही इक्वेशन आपको यूज करना है. इसके ऊपर हर साल क्वेश्चंस आते हैं, एंड लेट्स सी हम लोग इक्वेशन कैसे फॉर्म करते हैं. So assume that these are the salts. What would be the expression for the molar conductance for NaCl at infinite dilution? The expression would be like this. Molar conductance at infinite dilution, total molar conductance at infinite dilution will be equal to molar conductance of Na plus and molar conductance at infinite dilution for Cl minus. I can directly add them. Okay, in MgCl2, what I will do is I have one Mg2 plus ion, and there are two chloride ions which are given out per mole of MgCl2. Two moles of chloride ions given per mole of MgCl2. So I will write 2 times infinity Cl minus. ठीक है, एसिटिक एसिड के लिए क्या लिखेंगे? CH3COO minus plus H plus. Okay, we can write it like this. Very simple expressions. Na2SO4, I will write 2 times the molar conductance at infinite dilution for Na plus 1 times molar conductance for sulfate ion at equivalent at infinite dilution. In this case, this is potash alum. Potash alum will give 2 moles of K plus, 2 moles of Al3 plus, and 3 plus 1, 4 moles of sulfate ion. Okay, so if I have to write for this one, I would write it as infinity for K plus 2 times plus 2 times for Al3 plus and 4 times that for sulfate ion. Okay, now it is very vital to know that अगर मैंने ions की mobility calculate की, so let's say I take Li plus Na plus Cl K plus Cs plus. Of all these 4 cations placed in water, which will travel the fastest? Can you guys give me an answer? Of all these cations placed in water, which cation will travel the fastest? बताइए क्या होना चाहिए? Anybody? Which one will travel the fastest? The right answer would be Cs plus. The right answer would be Cs plus. Remember, if you look at the volume increases downward. Okay, as you go down the ions, as you go down the group, the volume of the ions increases. Charge is constant. The extent of to what extent it will move will depend on to what extent it is hydrated. Okay, to what extent it is hydrated. So extent of hydration is proportional to charge density. It is proportional to charge density. It means if the charge density is high, hydration is high, and if hydration is high, then mobility is less. Extent of hydration inversely proportional to mobility. Okay, extent of hydration is inversely proportional to mobility. जितना hydration होगा उसके around उतने water molecules surrounded रहेंगे and उसका movement उतना ही कम हो जाएगा. Now, if I calculate charge density is charge per unit volume. So charge density will be maximum for this. If I write, so charge density is density is maximum for this and charge density is minimum for this. If it is charge density is minimum, if charge density is minimum, less ions are surrounding, less water molecules surrounding it, and it will move faster. Okay, it will move faster. Clear? Now एक क्वेश्चन लेते हैं, एक सिंपल सा क्वेश्चन लेते हैं. इस चीज को समझने के बाद एक सिंपल सा क्वेश्चन लेते हैं. If I take H plus and I take Li plus, K plus, Na plus, which should travel the fastest? Which should travel the fastest? If I take all these ions, H plus, Li plus, K plus, Na plus, Cs plus, which should travel the fastest? I have taken all of them. इन सबको हमने कंपेयर किया है. कौन सा सबसे तेजी से मूव करेगा? सबसे पहली बात बताओ कि चार्ज डेंसिटी का ऑर्डर क्या होगा? चार्ज डेंसिटी order will be Cs plus will be minimum, followed by K plus, followed by Na plus, followed by Li plus, followed by H plus. यही होना चाहिए. Charge density will be minimum for Cs plus and maximum for H plus. If charge density is maximum for H plus, hydration, extent of hydration, will be also following this order. सबसे ज़्यादा हाइड्रेटेड ये होना चाहिए. Okay, most hydrated will be H plus. If H plus is most hydrated, it should move the slowest. Okay, if H plus is most hydrated, it should move the slowest. Do you understand this? Please tell me. Is this understood? Mobility looks like it should be maximum, so H plus should have the minimum mobility. H plus should have the minimum mobility. However, this is an exception. There's an exception to the rule. H plus has exceptionally high mobility. Why it is having exceptionally high mobility is because ये इस तरह से move करता है. It moves like this. Exceptionally high mobility for H plus can be explained using this model. In this model, what happens is that there are a lot of H2O molecules and H plus gets attached to one of the oxygen atoms and jumps from one oxygen to another oxygen. ये oxygen के पास से यहाँ पे jump किया, this oxygen gets a positive charge and then this hydrogen jumps. So this jump keeps on happening as many if the amount of H2O molecules increases. Okay, so it is so amazing technology which has more hydration. Hydration would be higher for H plus, but H plus has exceptionally high mobility because of some other reason. The movement does not take place like this. Movement takes place like H plus is hopping on each of the H2O molecules. जितने उसके H2O molecules के आसपास हैं उनके ऊपर से hop करके वो जा रहा है. Okay, so this H plus just moves from here to here. Because this H plus moves over here, this H plus moves over here. So effectively H plus is moving along a chain. Okay, so that is the reason. Please do remember that H plus has exceptionally high ionic mobility, and it is because of this phenomenon. Okay, it is because of this phenomenon. Okay, chalo. Let's try to solve a question. The first problem, let's try to solve the first problem. Molar conductance at infinite dilution for NaCl, HCl, NaAC are 126, 425 and 91 centimeter square per mole. I have to calculate molar conductance at infinite dilution for HAC. AC is the representation for acetate. Okay, AC is the representation for acetate. Now इस क्वेश्चन को सॉल्व करने से पहले मैं ये बता दूं आपको कि जो वीक इलेक्ट्रोलाइट था, वीक इलेक्ट्रोलाइट के लिए प्लॉट कैसा आया था, इस तरह का. वीक इलेक्ट्रोलाइट के लिए प्लॉट इस तरह का आता है, मोलार कंडक्टेंस वर्सेस कंसंट्रेशन. द प्लॉट गोज लाइक दिस. सो इट डज नॉट टच द वाई एक्सिस. It is experimentally obtained and it does not touch the y-axis. Since it does not touch the y-axis, I cannot calculate the molar conductance at infinite dilution experimentally, but mathematical manipulations इसको हम calculate कर लेते हैं. कैसे calculate करते हैं देखिए. Can I say, so I'm erasing this part, can I say that molar conductance at infinite dilution for NaCl will be equal to molar conductance at infinite dilution for Na plus, and that will go for Cl minus. Can I say this? ये मैंने पहले निकाला. Okay, this we have calculated earlier, so I will get this. I can write it for HCl as well. Which will be equal to H plus Cl minus. Okay, and I need to calculate it. I have for NaAC, so I will write this as I will get like this. Okay, I will get it like this. Now remember, when I take this and I have to calculate it for HAAC, तो HAAC का हम क्या लिखेंगे? HAC would be written as infinity for H plus and I have to use the first three equations, equation 1, equation 2, equation 3, so as to get this expression. देखो, मुझे पहले तीन expressions को use करके fourth expression निकालना है. So how do I manipulate the first three expressions so as to get the fourth expression? How do I manipulate the first three expression to get the fourth expression? What I will do is I will add 2 and 3 and subtract 1. Can I do this? If I add 2 and 3 and subtract 1, can we get this fourth equation? बताइए. If I add 2 and 3 and subtract the first equation, can I get the fourth equation? देखो, if I add 2 and 3, this will be added up, and if I subtract 1, then this will go away, this will go away, Cl minus will go away, Cl minus will go away. What would be left out? What would be left out is this and this. And finally, if I add both of them, I will get the final result. So I have to add second is for HCl, third is for, so I have to add these two values and subtract this value. So 425 plus 91 turns out to be 516.9 and 126.4. अगर हम subtract कर देंगे, our answer should come as to be 390. The right answer should turn out to be 390. Okay, the right answer should turn out to be 390. A नहीं होगा answer. People who are writing A are making a mistake. Please do the calculation. Simple addition subtraction करना है यार. ओके, सो इसको ऐड करके इसको सब्ट्रैक्ट कर दीजिए, दैट इज योर आंसर. ओके, चलिए लेट्स टेक द नेक्स्ट क्वेश्चन. दिस क्वेश्चन केम इन JEE this question came in JEE Mains 2019, the January paper, and we have to solve this question. इस क्वेश्चन को हम सॉल्व करेंगे. बहुत सिंपल सा क्वेश्चन है. लेट्स लुक एट द क्वेश्चन. मोलार कंडक्टेंस, नॉट का मतलब भी इंफिनिटी होता है. ओके, दिस नॉट मीन्स मोलार कंडक्टेंस एट इनफाइनाइट डाइल्यूशन for NaCl, HCl and Na is given as 126, 425.9, 100.5. If the conductivity for HA is this, degree of dissociation for HA is to be calculated. Okay, कैसे calculate करेंगे? इसको दो parts में solve करना है हमें. We have to solve this in two parts. First, I will calculate for HA. I will calculate molar conductance for HA. What is the molar conductance for HA? क्या होना चाहिए? I will take molar conductance for at infinite dilution for HCl, add it to molar conductance at infinite dilution for NaA and subtract molar conductance at infinite dilution for NaCl. ठीक है? I will subtract that by adding. These two would be added and this has to be subtracted. Okay? I will get what answer? 425.9 plus 100.5 minus 126.4 minus 126.4. कितना आंसर आएगा बताइए? 425.9, 100.5, so 95416, तो ये हो जाएगा 526.4 minus 126.4, which gives me 400 Siemens centimeter square per mole. Centimeter square per mole. This is my conductance. I have to calculate conductivity is given. Degree of dissociation निकालना है. Okay? तो conductivity दिया गया है. Degree of dissociation कैसे निकालेंगे? देखो, you are given conductivity, that is G is given. Conductance is given. You will write this thing as 1000 times K upon C. This is the concentration. Okay, you will write it like this. What is the actual value of conductance for this? कितना होना चाहिए? 1000 times 5 times 10 raised to minus 5 upon C is 0.001. So this will be 10 raised to 3, 10 raised to 3, 10 raised to 6. This will turn out to be how much? This will turn out to be how much? कितना हो जाना चाहिए? This is 10 raised to 3 and this, इसको हम ऊपर 10 raised to 3 लिख देंगे, so 10 raised to 6. This will turn out to be 50. This will turn out to be 50 Siemens centimeter square per mole. So this is giving me what? This is giving me lambda m. And this is giving me lambda infinity. Alpha value is equal to lambda m upon lambda m at infinite dilution. Okay, lambda m that we have calculated over here divided by whatever is obtained for infinite dilution. So 50 upon 400, the right answer should be 50 upon 400, right answer should be B. Okay, 50 upon 400 should be B. ठीक है, the right answer should be B. So JEE Mains का question है 2019 में आया है, but question is very simple. Okay, question is very simple, घबराना नहीं है. Electrochemistry easy topic है. Okay, and this is the problem, a homework problem for you guys. So there is a graph plotted between the molar conductivity of various electrolytes NaCl, HCl and NH4OH and root C correct setting is, which is the right graph. Please do comment about this in the comment section. ये आपका homework problem है. Now, this is the final theory session on electrochemistry. The next session on electrochemistry would be a problem solving session. उसमें हम सिर्फ problem solve करेंगे. Okay? We will solve only problems, and problems will be from JEE Mains past few years question, or it could be from JEE Advanced as well. So please do review the whole of electrochemistry for the Monday session, and जितना easily आप question solve करोगे क्लास में, उतनी easily आप examination में भी solve करोगे. So just don't worry about the difficulty of the topic. Just make yourself familiar with all the concepts, all the equations, and easily हो जाएगा. Okay? So with this I take leave. But remember, today is a session, a KPY session SX के लिए एक chemistry lecture है आज, and that is on thermodynamics and equilibrium. Please do join us on the channel for that lecture, because that lecture was supposed to be held yesterday, but Independence Day थी, रक्षाबंधन थी, तो वो हो नहीं पाया. वो session आज live जाएगा. Please do watch that session for KPY SX. Okay? So the timetable is updated on the channel. So please go through the previous sessions to know about the KPY timetable. It's generally held between 8 to 9 o'clock. Okay? 8 o'clock एक session होता है, 9 o'clock एक session होता है. ठीक है? So with this, I Saurav Goswami take leave, and next class में please do join कीजिए, क्योंकि उस दिन हम question solve करेंगे. Okay? Bye bye guys, and have a lovely time.